All right, guys, so here's what we learned on Monday. We learned that if something has an exponent and that exponent is a fraction, then you can write it as a root. So we learned that x to the inside over outside. So if we have something that's raised to a fraction, we can write it as a root. The base of that, below it, whatever that is, like sometimes that's a number and sometimes that's a variable, that part stays inside. The numerator of the fraction stays inside. The denominator of the fraction goes outside. And we can only do this if the exponent's a fraction. All right? So for number 1 here, I've got 2 exponents, and both of them are fractions, which means I can write this as 2 roots. For the first part, the 243 is the base. It's below the 1/5. So I'll write this as a 243. The numerator stays inside, the denominator goes outside. So I've got a 5th root of 243, the first. For this one, the x is the base. It's below, so that stays inside. The numerator is inside, the denominator is outside. Now from here, I would do 243 to the first power, just to write that as a single number and get rid of that exponent. Anything to the first power just stays the same. So this is the same as this. And this is called a coefficient. So the first thing that we do with coefficients is we check them with math 5. So I'm going to math 5 the 5th root of 243. And I get a whole number there. And so I'm going to change this to just a regular 3. And what we learned about exponents is if the inside number, 4, is less than the outside number, 5, then we don't have to do anything. That part of the problem is done. So I'm just going to leave that part of the problem the same. And so my final answer in what's called radical form would look like that. 3 on the outside and then the 5th root of x to the 4th. Anybody have questions on that one? Now I changed number 2. I think in this class alone, we didn't do one like this. I think I ended up switching it block 2 so that they could see an example like this. So you haven't seen this. So my guess is you might have this one wrong. Okay. Notice that the 15 is not touching an exponent, yes? That exponent belongs to the x. It does not belong to the 15. I can only write something in a root if the exponent is a fraction. But the 15 doesn't have an exponent at all, which means I can't write the 15 in the root. Did anybody catch that? Put the 15 outside the root? Nice. All right. So the 15 is just going to stay as is. It's not going to go inside of the root. It's not going to go inside the root because it doesn't have a fraction. All right. The only thing with the fraction here is the x. So I can write the x in the root. The x is the base, so it stays inside. The top is my inside number. The bottom is my outside number. Now in this case, when I'm simplifying that root, the inside is not less than the outside. So I'm not done. I'm going to have to split this up. And the way that we split up variables is we think of multiples of the outside number. So when I'm doing this one, I want to think of multiples of 7. 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, 7 times 6, 7 times 7. 7 times 8 is too much. 56 is over, right? So you want to get to the point where you go over the number and pick the one directly in front of that. So I'm going to make one of these a 49. What would the other one have to be? Andrew? 3, right? I needed to add to 53 still. Again, all the while, this 15 is just coming along for the ride. It didn't have its own exponent, so I can't do anything with it. All right? 49 goes into 7. 49 divided by 7 is 7. You just can't forget that there's still an x there, so that's x to the 7. And when the inside is smaller than the outside, then that part of the problem is done. And then again, the 15 is just coming along. This is radical form for number 2. What's different about this one is that 15. Because it doesn't have an exponent, we're just bringing it along. All right, last one. We've got two exponents, so we're going to have two roots. The base on the first one is a 9. The numerator is 2, the denominator is 3. The base on the second one is x. The numerator is 20, the denominator is 3. So I'm looking at these two roots. Now 9 squared is not 18. It's 9 to the power of 2, or you could do 9 times 9, 9 2 times. Okay, so either way we're getting an 81 here. I can write this as the third root of 81. Now because that's a coefficient, I can math 5 it. But it's a decimal. Where do I go if I get a decimal? Y equals. I'm going to go to y equals, and I'm going to do 81 divided by x. And what I'm looking for here is a perfect 3. So if you go to this list, I'm going to skip the 1 part. I'm looking for an 8. I'm looking for a 27 or a 64. It's not going to be bigger than 81 itself. So really I'm just focusing in on those 3 numbers, 8, 27, or 64. Do we see any of them here? 8, 27, or 64? 27. Next to the 27 is a 3. So I'm going to use 27 and 3. All right, so break that up. Now I'm going to, because they're coefficients, I'm going to check them both. Sometimes kids think that this is going to be 1, but you can see it's not 1, right? So I'm going to change the third root of 27 to a regular 3, but I'm going to keep the third root of 3 the same because this is nicer than this. All right, that takes care of my coefficient. Now, with my variable, my inside is not smaller than my outside, so I'm not done. I need to think of multiples of my outside number. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7 is too much, right? So I'll know that I'm done when I go over the current exponent. I'm going to use the one directly in front of that. So I'm going to use the 18, which means the other number is going to have to be 2. I still need it to equal that 20. 18 divided by 3 is 6. I just can't forget about the x. And when the inside is smaller than the outside, we don't have to do anything there. My final answer, I just want to do some rearranging. So I'm going to take this and I'm going to write it next to this. And I'm going to take this and I'm going to write it next to this. 3x to the 6th, third root of 3x to the 2nd. The question is called exponential form because there's exponents. The answers are called radical form because there's roots. I need you guys to know the difference between the two. What exponential form is versus what radical form is. Today we're going to do the opposite. So instead of here's exponents, you write radicals, we're going to do here's radicals, you write exponents. It's actually a lot easier. We got the hard one out of the way. All right? So today we're going to work backwards. I think you're going to find it pretty easy because once you know how to do it one way, it's not like earth-shattering to do it backwards. So we are going to be in your toolkits and workbooks today, and we're going to work from going from radical to exponential. This is in your toolkit. It's on page 4. You could probably fill in this top box on your own right now, okay? It's not any different than the box filled in on the page before. I just reversed the order. Anybody think they know what this fraction's going to say? It's going to use the words inside and outside. Which one's going where? Andrew?
1 over 3.
Huh?
Yeah, 1 over 3. Was it 3 over 1?
Oh, not this one. Sorry, this one. I want words here. You're right, though. It is 1 over 3. What words go in this box? inside over outside, all right? So now we're going to be given it in radical form. The outside number is going to be outside and the inside number is going to be inside. You're going to take whatever this bottom number is inside and make it your base. And then the inside exponent will become the numerator of your fraction. And whatever little number is on the outside will become the denominator of your fraction. So for the example of the first problem, I've got the 125, but I don't have an inside exponent. What do you think we could write if we don't have an inside exponent? 1. So the inside exponent is 1. So the base is 125 and the exponent is 1. So the base is where the x is, that's the 125. The inside exponent is 1 divided by the outside number, which is 3. If there isn't an exponent inside, you have to write a 1. All right, so what we're going to do from this, we're not going to math 5 it because it's not a root. We're just going to type it into the calculator the way that it looks. You don't have to do anything fancy with parentheses or anything like that. So you're going to do 125. The power button is below the clear button. I have it highlighted in red up there so you can see it. And then I'm just going to do 1 divided by 3. What we're looking for is a whole number. It's 5, right? So math 5 is when you're checking a root. If you're checking an exponent, you can just type it in the calculator as is. So this is just 5. We okay with the first one? All right, let's look at the second one. The fourth root of 16. Now, the inside, again, doesn't have an exponent, so I'm going to make an exponent. I need an inside exponent. So my base below that new exponent is a 16. And then my power is going to be the inside exponent over the outside number. And I'm just going to type this into my calculator. I'm not going to math 5 it because it's not a root. I'm just going to type it in the way it looks. So 16 to the power of 1 divided by 4. So I get 2. So the answer to this one is just 2. Everybody okay so far? All right, looking at the next one, my base, the bottom number is 216. My inside exponent is 2, so that's the numerator of my fraction. My outside exponent is 3, so that's the denominator of my fraction. And now I'm just going to type this into my calculator and see if I get a whole number. So we'll do 216. Just don't forget the power of button is here. 2 divided by 3. So I get 36. This one is 36. So you guys take a moment. You're going to try this one. It should be fairly quick. Someone tell me what you're typing in your calculator. Not the answer. What did you type in your calculator for this one?
625 to the power of 3 divided by 4.
Very good. 625 to the power of 3 divided by 4. And I'm assuming that's a whole number. What did we get? 125. So we're typing it in our calculator. If we get a whole number, we're going to change it. We're not always going to get a whole number, though. So when you look at these examples, it's the same idea. I'm still going to do inside divided by outside. All right, so if the inside doesn't have an exponent, give it a 1. So the bottom number, the base, is 2048. The inside exponent is 1 divided by the outside number is 3. When I go to type this in my calculator, I get a decimal. Now, normally, I would go to the y equals screen, and I would try to split this up, but this isn't a root, right? I'm not simplifying a root, it's an exponent. So the really, really nice thing about this is, I'm just done. I don't have to do anything else. If you get a decimal in this format, you have done as much as you can. This is just the answer. Whereas with radicals, with those decimals, you gotta go further. You gotta break it down. You can't break down an exponent. It just stays the way it is. So that's it. Moving on. So if you type it in your calculator and you get a decimal, leave it and move on. All right, so let's look at this next one. There's no exponent on it, so I put a 1. So I'm doing 405 to the power of 1/4. And if I type that in my calculator, since I don't get a whole number, I'm just leaving it as is. All you're doing with coefficients is typing it in your calculator. If you get a whole number, change it. If you get a decimal, leave it. That's it. That's not the same for roots, right? For roots, you got to do all the stuff. But for exponential, pretty basic. All right? So what do you think this one's going to look like in exponential form? You tell me. They're going to make me do like a random name generator on Power School. And then on Power School, what happens is your face comes up. I hit random, and it's like the seating chart, and then your face pops up on the screen. Do you guys want to see your face on the screen? Someone raise your hand and tell me what this is in exponential form. Thank you.
686 to the power of 1/10.
You guys should thank him. He just saved you. All right. If I type that into the calculator, I'm assuming it's a decimal, but I'm going to do it anyway just in case. Decimal. And that's it. All right. Radical to exponential form is a lot easier. We got the hard one out of the way. Exponential to radical takes a lot longer because you've got to go to your y equals screen. You've got to simplify. You've got to split up the variables. All right. So we can do the same thing with variables. It's just we're not going to be typing anything into our calculator because with variables, the calculator doesn't know what x is. So my base here is 12. My inside exponent, my base is x. My inside exponent is 12, so that's my numerator. And there's my denominator. The only thing that you can do with variables is to check to see if this simplifies. I'm not going to put the x in the calculator though. I'm just going to put, you probably know what 12 divided by 4 is. So I'm just going to put the 12 divided by 4 into the calculator. All right, so sometimes that might be a decimal and you're going to need to math enter, but you know that 12 divided by 4 is 3. So the only thing you have to do is see, does the fraction that I get simplify? So for this next one, my base, my bottom number is x. My numerator would be 12 and my denominator would be 5. So all I would do here is check if 12 divided by 5 reduces by hitting math, enter. If it doesn't reduce, then you're just going to leave it alone. But if you have something like 4/8, I need you to write it as 1/2. So all you're doing is simplifying fractions here. And you don't actually have to simplify them on your own. The calculator will do it for you. All right, so x to the power of inside over outside. Does 17/3 reduce? No, that one's done. B is the base here to the power of inside over outside. Does 10/5 reduce? So this one is going to be b squared. All right, all you have to do with fractions that are variables is see if the fraction itself simplifies. If it does, simplify it. If it doesn't, leave it alone. So last part here, I believe, is just putting it all together. Having some that are numbers and having some that are variables. Just know that if it's under the root, then it gets its own fraction. So see how this 48 here doesn't have an exponent on it? I need to put 1. All right, so I am going to put a 1 on the 48 because both the 48 and the y are under the root, which means they're each going to get their own fraction. So the 48 is going to have its own fraction exponent, and the y is going to have its own fraction exponent. The 48's inside exponent is 1, and the outside is 4. The y's inside exponent is 13, and the outside is 4. You just got to make sure that if it's under the root, they each get their own fraction. Now, for regular numbers, we type them into the calculator. 48 to the power of 1 divided by 4. It doesn't simplify. So I'm going to leave the 48 to the 1/4 alone. For variables, I'm just going to check on that fraction. So 13 divided by 4, math, enter, enter. That doesn't simplify either. That means that this is done. If this became a whole number, I'd need to change it. And if this fraction reduced, I'd need to change it. Those are the only 2 things you're checking. So here, I've got a 128. I got to give that a 1. So I'm going to have 3 different things with their own exponent. The 128 is going to have a fraction. The x is going to have a fraction. And the y is going to have a fraction. The inside number on the 128 is a 1, and the outside is a 7. On the x, it's a 21, and the outside is a 7. And on the y, it's a 3, and the outside is a 7. Coefficients, 128 to the 17. I've got to check like this. Since that becomes a whole number, I'm going to change it. If it was a decimal, I would just leave it as 128 to the 17. 21 over 7 is 3. You probably already knew that, but that means that I'm going to change the x to a 1/3. And then 3 divided by 7 doesn't reduce, so I'm going to leave that as 3 divided by 7. So my final answer looks like that. We okay with that? All right, so you guys take, let's say, 2 minutes and try n and m. We'll go over to day 10. Anybody know what that? All right, the 27 needs an exponent, so I'm going to give it a 1. 27 to the 1 over 3, d to the 5 over 3. If you type this into your calculator, it's 3. If you try to reduce that, it doesn't. So the final exponential form for this radical, so radical to exponential, the final exponential form is 3d to the 5/3. That 224 needs its own exponent, so I'm going to give it a 1. 224 to the 1/5, x to the 25ths, y to the 7/5. If you type this into the calculator, you get a decimal, which means you're going to leave it as is. There's nothing to do to that. But 20 divided by 5 reduces to 4, so I'm going to change that. And 7/5 does not reduce, so I'm going to leave that as 7/5. This is exponential form for O. That's a lot easier, right? You don't have to do as much. So what we're going to do next, we've got 2 things. The first thing is I'm going to have you do just a 10-minute quick practice. Yeah, 10-minute quick practice. You can do this with a partner or a group of your choosing. You can do this on your own. I don't care. I'm going to set a 10-minute timer. You don't have to get through all of it. Get through as much of it as you can in 10 minutes. So you're going to do page 16 and see how much of it you can get done. As the timer gets closer to the end of 10 minutes, so around like 8:22-ish is when we're going to be ending, I want you to make sure that you check your answers because we're not going to go over this. And then we'll do, at the end of class, we're going to do a Kahoot, and I got some prizes. All right, so we're just going to try to do practice to make sure we're okay with that. All right, so I'm going to set a 10-minute timer. You're doing page 16. You can work with somebody. You can work with a group of people. You can work on your own. When you're done, check the answers. 10 minutes, we're going to move on. I do not, but if you want to go get some at the nurse, that would be lovely. Thank you. All right, 10-minute timer. I want to do some 90s today. 90s hits, best of the 90s. Best of the 90s. You guys weren't allowed. What's up? Need help with one? Sure. just this for 10 minutes. We've got 6 minutes left, and we're going to do a computer again.
Probably on. But when he was like, oh, yeah, tomorrow. I'd be surprised if it was for that.
What's up? You don't have that table. Not yet. Get my snacks ready. Of my food.
Bro, it's always something in his mind. It's always something. It's always some constructive response to the
It is.